We're taking a look at our factoring review. This is number 3. So these are just factoring by GCF. Now, what does it mean when I factor? Nope, does not mean to make it smaller. It does not mean to simplify. It does make it smaller. It does simplify it per se, but that's not what it means. If I factor something, like if I want to know 2 factors of 12, you would tell me 3 and 4. That'd be fine. So what does that mean? I'm looking for, okay, or numbers that multiply to be that number, okay? So I'm wanting to know, with this trinomial, I'm wanting to know what 2 polynomials multiply to be that trinomial, okay? So the first thing I say is it does have a GCF. What can come out of 16, 8, and 36? A 4. Okay, can I take any p's out? No, because the first term doesn't have a p. So I would have 3 blanks, because if I'm going to take a 4 out, I got to take it out from all 4 terms. When I divide a 4 out, I'm left with 4. When I divide a 4 out from the 8, I'm left with 2p squared. And when I divide a 4 out of the 36, I'm left with 9p cubed. And so what would one of the factors be? 4, your GCF is one of your factors. What would another factor be? 4 plus 2p squared plus 9p cubed. That trinomial. This is a monomial times a trinomial. That's the answer. These are the 2 factors. Gotcha. No. Yeah. 4 is the greatest common factor, but when I say factor this, I'm wanting to know what 2 polynomials multiply to be your first question. So those 2, that monomial times that trinomial, are your 2 factors. Okay? All right, let's go down to 5 through 8. Pick one. Well, let's do 5 through 8 first. Let's do one of the easy ones first. These are your easy trinomials. I hear 7. 7. All right, here's number 7. M squared plus 6m plus 8. Okay. My first thought is there a GCF? No, there is not a GCF. There's not a number that can go into 1, 6, and 8 other than 1, but 1's not going to do us any good here. Okay. So then I look at it and say, okay, it's a trinomial. So we're going to try to factor it like a trinomial. We know that trinomials break down into 2 binomials. And here's our reverse of FOIL. First times first is going to give me my first part, which is m times m. Last times last is going to give me my 8. And so give me numbers. What multiplies to be 8? I hear 4 and 2, or you could use 8 and 1, but why are we saying 4 and 2? Because it's going to add to be 6. So you put your plus 4 in, your plus 2 in, and so that does work. M times m is m squared. Your outer gives you 2m. Your inner gives you 4m. And your last gives you 8. And when you put them together, you do get a plus 6m in the middle. Okay, so you have to, remember I said it's like a puzzle. You got to figure out what multiplies to be the last that will add to be the middle. Okay, do I need to do any others on 5 through 8? Are you okay with easy trinomials? Okay. All right, so then you have problems like 9 and 10. 9 and 10 are easy trinomials, but they have a GCF. So do you want to see either 9 or 10? All right, here's 10. So 4p squared. And again, you need to know how to factor. If I'm going over this again, you need to know this. You're going to see, regardless, we're going to learn how to solve quadratics. Are these quadratics? Yes, that is a quadratic trinomial. When I add an equals 0 on it, it becomes a quadratic equation. You with me? So we're going to learn to solve today by factoring, but they're going to ask you just straight factoring questions on the SOL, and you need to make sure you know. Okay? So what they might do on this is they might give you like 8 different choices, and they say name all the factors of this. Okay? So first of all, does it have a GCF? Yes. What can come out of 4, 12, and 216? 4. So I'm going to take a 4 out. I'm left with 3 blanks. When I divide a 4 out here, I'm left with p squared minus 3p minus 54. Then, do you remember my babushka dolls? Okay, remember I said sometimes you can take what you have left and break it down even further. So if I look inside here, I'm left with an easy trinomial. So I can take this easy trinomial and I can break it down even further. First times first is p times p. Last times last is negative 54. Somehow, though, I've got to, am I going to be adding or subtracting to get 3? Subtracting, because my signs are going to be 1 positive, 1 negative. So tell me numbers that 9 and 6. 9 times 6 is 54, and when you subtract 9 and 6, which one needs to be negative? Negative 9 and a positive 6. Remember, the larger one needs to go with your middle sign. Okay? And that does work. When you have a negative 9 and a positive 6, that will give you a negative 3. So, on the SOL, they'll give you things like this. They'll give you p plus 9. They'll give you p minus 9. They'll give you 4p minus 36. They'll give you p plus 6. They'll give you p minus 6. They'll give you 4. They'll give you 2. They'll give you 4p plus 24. Okay? And so, which ones would be my answer? Which ones are the factors? P minus 9, p plus 6, and 4. Okay, don't forget, who's this? Don't forget Bob. Okay, I've also seen them say, what is one of the factors? And they give you all these crazy ones. They give you all 3 of those, and then they give you p minus 6, and then they give you p plus 9. And so they say, what's one of the factors? What's one of the factors? 4. And so everybody's getting all like, if you forget about Bob and you're sitting there and going, wait a minute, but that doesn't work, and those signs don't work, and I see you pulling your hair out. Don't forget, 4 is a factor. It's a monomial. Okay, so in that case, you would have 3 factors. Okay, let's go down to 11 through 14. Pick one. 12? All right. 5n squared minus 47n plus 18. Okay. Does this have a GCF? No. Then you look at it and say it is a trinomial. So you'll try to factor it like your trinomials. But what makes this different from the ones I've just done? You're going to have to multiply something with the 5. Remember I gave you the juggling analogy, and I said, okay, you start with 2, and once you get really good with 2 apples, you then move to 3. Well, that's what I'm doing. I'm throwing in an extra apple this time because I'm throwing in that 5 in front. And because of that 5 in front, it makes it a little more difficult, but it's still the same thing, right? Okay, so first times first is 5n squared, which is 5n times 1n. Last times last is 18. Now, first of all, what will multiply to be a positive that's going to add to be a negative? 2 negatives. Okay? Everybody with me? So you know your signs need to be negative. Now you have lots of choices for 18. You got to figure out which puzzle piece will work. And it's not what multiplies to be 18 that adds to be 47. Whatever you put out here is going to have to multiply with the 5. So the 5's in with it too. So you got 3 and 6, you got 9 and 2, you got 18 and 1. What do we want to start with? Evidently, people have already done this and says 9 and 2. I would start with 3 and 6, because remember I said always start with the two that are closest, but evidently a lot of you have done that and it didn't work. So I hear 9 and 2, so we'll go with 9 and 2. So I'm going to stick my 9 right here because I'm already looking at this, seeing what? 45, and man, that's so close to 47. And when I put my 2 there, that is going to get you to negative 47 in. And so that's what you're going to want. Okay? But we call this trial and error. You try it, you erase it. If it doesn't work, okay, which part's your answer? The middle part. So the 2 factors, right? So what's one of the factors? 5n minus 2 and n minus 7. Okay. Do you need to see another one, or are you okay with that? Mm-hmm. Pick one more. 13. Borrow a what? Yep. Okay. So again, no GCF. My first thought, that always needs to be your first thought. The minute you say factor, you need to think GCF. And look for that GCF, because if you forget about Bob, that's going to be a problem. So, first times first is going to give me 3m squared. Quit. What times what is 3m squared? 3m times m. Last times last is 8. So you got choices of 4 and 2 or 8 and 1. So why am I hearing 8 and 1? Because that's the right answer. And when you put an 8 there, I'm already looking ahead because that gives me 24. And 1 will give me 25 in the middle. Okay, which is what I want. Okay? Again, the more of these you do, the better you get at them. And when you do them all day long, you get real good at them. Yeah. Okay? All right. Can I go down to one from either 16 through 20?
Yeah, me either.
Oh, 15? All right. Well, let's look at 15 first. Shh. 57 in. All right. So first times first is 8n squared. You got choices. You can do 4 and 2, or you can do 8 and 1. And so I'm guessing if you got stuck on it, you were trying to use 4 and 2 the whole time. Don't forget, though, you do have a choice of 8 and 1. Last times last is going to give you a negative 56, and because it's a negative, you need 1 positive, 1 negative. So you got lots of choices. I think I got my signs backwards. Because you got 8 and 7, you've got 2 and 23, you got 56 and 1, but we would always start with 8 and 7. And so I'm thinking put the 8 here and the 7 here, because that's going to give me 64 in. This is going to give me minus 7 in, and when you do 64 minus 7, you get 57. Okay? Does that make sense? All right, let's go to 16 through 20. Which one do you want to hear see? All right, they are easy. You have to recognize that these are your perfect squares. Does everybody see that we have perfect squares here? So this does break into 2 binomials. First times first. What perfect squares multiply to be 9v squared? 3v and 3v. Last times last gives you negative 25, so you need a positive 5 and a negative 5. And because you have one of each sign, If normally when we multiply FOIL out, we end up with 3 terms, right? First, outer, inner, last. Okay? But why do we not have a middle term? Because they cancel out. And if you look at that, this will give you a negative 15v, and this will give you a positive 15v, which cancel. Okay? Which is why you only have a first and a last. Okay? Do you need to see one more on the difference of 2 squares? Is it always a plus and a negative on a difference of 2 squares? Yeah. What if I give you this on the SOL? So will it work? This is not a difference of 2 squares. This is a sum of 2 squares. And remember, we worked this out. Remember, would 2 positives cancel out? No, it won't work. And would 2 negatives cancel out? No, it won't work. In order for it to cancel out, it's got to be a difference of 2 squares. So what do we say about ones like these? Yeah, what? Or they're not factorable. Okay? So don't forget about those. Do y'all remember those? Okay, they are not factorable. All right, so if you will, put this away, get out new notes. Okay, nope. Objective 36. Sorry, not today. It'll be all right. Okay. So now that you know how to factor, what we're going to do is we're going to take factoring to learn how to solve these quadratics. Okay, now do not forget that if you put this in your calculator, you will either get, just reminding you of this, you'll get a parabola, okay? And in this case, this one would have 2 answers. And you are looking for where it's crossing the x-axis, okay? Don't forget, if you have one that looks like this one only has 1 solution. And then sometimes you have one that looks like this that has no solutions. Okay? Any questions on that? No real solutions. When you get into Algebra 2, you'll figure out that it has a solution, it has imaginary solutions. But in Algebra 1, just know that it has no real solutions. How about that? Okay? Just know that. So that's what you're looking for. When we look at example, what I'm going to show you to do today is we're going to solve these by factoring. Okay? So what we're going to do is we're going to, as long as it's equal to 0, you can try to factor it. Now, what if it's not factorable? Not every problem is factorable, correct? So, what do? No. You do it another way. And then the other way that so far that we know is graphing. So you might put in your calculator. You with me? You can't do every single problem by factoring. Okay? Most of them can be factored though. And so I will say if you're pretty good at factoring, you'll like this way. Okay? So what we're going to do is we're going to take this trinomial and we're going to factor it. Okay? Does it have a GCF? No. So we're going to take it and split it into 2 binomials. First times first is going to be x times x. Last times last is positive 3 and a negative 1. Did everybody agree that 3 times 1 is 3? And a positive times a negative is a negative? And when you add 3 and negative 1, you get a positive 2. Everybody understand that? And if you need to do your factoring and your checking on a separate sheet, you may want to do that. Does that make sense? And leave your problem here.
There don't be any really, really hard factors, like really humongous numbers.
Not too bad. Okay. I'm not done though. I'm not done. I'm still looking for where it's crossing. Okay. So, answer me this. Blank times blank equals 0. What can you tell me about those blanks? In order for it to equal 0, one of them so either this one has to be 0. Would it matter what that one is? No, but if that was 0, you get 0, right? Or this would have to be 0. One of these two blanks has to be 0 in order to equal 0. You follow me? So, do you see our two blanks that are being multiplied that equal 0? So what are you telling me about these two blanks? What would make this whole blank 0 if x were what? No, 0 plus 3 is 3. Negative 3, right? Because a negative 3 and a positive 3 would make this whole blank 0. That's one of your answers. What would make this whole blank 0? 1. 1 minus 1, the whole thing would be 0, right? That's your other answer. So what we do, so that you don't have to do this in your head, but that's what it is we set each of these equal to 0. So you're telling me that either this whole thing has to be 0, and so when we solve for this, x would be negative 3, which is what you just told me a minute ago, right? Or x minus 1 has to be 0. So when you solve for this, x would be 1, which would tell me. So those are your two answers. So if you looked at this, if you put this in your calculator, it would look something like this. 1, 2, 3, 1. Would this be a u or would this be an n? Is x squared positive or is x squared negative? Positive, so it's going to be a u. So it would look like this. It would cross at negative 3 and it would cross at 1. Okay, let's look at another one. I've only done one, just hang tight. I think you're going to like it. Okay. How am I going to factor this one? First of all, is it equal to 0? If it's not equal to 0, you got to make it equal. You got to move it over, make it equal to 0 first. Okay? So I hear GCF on this one. Did everybody agree GCF? So what can I take out of 4n? And so I would have left, if I divide a 4 out and I divide an n out, I'm left with n minus 5. Do I still have two blanks that equal 0? What's my first blank? 4n, a monomial, times a binomial equals 0. So, tell me, just using our CS brains, what 4 times what would give you 0? 0. So what does that tell you? It's crossing through the origin because it's at 0. What would make this whole thing 0? Positive 5. Those are your two answers. But algebraically, what we do is we take each of these and set them equal to 0. So 4n would equal 0. So when you solve it, n is 0, which is what you just told me. Okay? And then n minus 5 equals 0. When you solve this, n would equal 5. Okay? So again, if you looked at this, if you punch this into your calculator, okay, it should be crossing at 0 and 1, 2, 3, 4, 5. Positive 5. And so it looks something like that. Okay? Why don't you take a minute and punch that in. Put in y equals 4n squared minus 20n. Check. Does it cross at 0 and 5? And hit your graph button. Does it cross at 0 and 5? But we did this by factoring. Okay?
Really, never really, once you get up to X, you don't really ever have to use factoring. You use graphing every time. She gives us a factor.
So some people are going to like the graphing the best. And some people are going to like the factoring. How many? We got to do more factoring. But so far, how many like graphing the best? How many like factoring? I think, to me, a lot of these, I can already like eyeball and see. Like, for example, example 3. Nope, it's not. It's another one. I have a different one for you. Sorry. It just had good examples on it. So I can already eyeball this. This is a trinomial. What multiplies to be? No. You got to add to be negative 5. 6 plus 1 is 3 and 2, right? Negative 3 and negative 2, right? But what do you notice? So when I factor this, x times x, and it's negative 3 and negative 2. Everybody agree with that? Negative times a negative is a positive, and when you add negative 3 and negative 2, you get negative 5. But what do you notice? The factors are negative 3 and negative 2. What are my answers, though? What's going to make this 0? Positive 3 and positive 2. So notice that your answers are opposite from your factors. Yeah, from your signs when you factor. But in my head, I can do that. I can look at this and say the answer is going to be 3 and 2. And I don't have to do anything in my calculator, and I can just do it and see it. But what you would do from here is you would set them equal to 0. When you move this over, x would be 3. And when you set this equal to 0, when you move this over, x would be 2. So again, if you looked at it in your calculator, it would look 1, 2, 3. It would go down through 2 and back up through 3. Okay? Questions? No, not necessarily. Yeah. He said, do you have to do all this? Like, if I can tell you that x is 3 and x is 2, do you have to do all this solving? Not necessarily, no. Okay? But that's just kind of, what you do if you can't tell. Okay? And sometimes you can't tell. Like, for example, what if your factor, if you get one that looks like this, and it's 2x minus 3 times 5x plus 4. Now, this came from an advanced trinomial, right? Because it's got coefficients in front. But can you guys tell me what's going to make this whole thing be 0? So this is why I show you. Does that make sense? This is a harder one. So if you can't see it, you would have to set it equal to 0, move this over, and you get 2x equals 3, and then you would divide by 2, so x would be 3 halves. Is it okay that it's a fraction? Yes, that's fine. Okay, and then if you moved this one over, plus 4 equals 0. So sometimes you're going to have to set it equal to 0 if you can't really see it. So when you divide by 5, x is equal to negative 4/5. So do realize, if they've given you one like this already on the SOL, does that make sense? You need to be, and they'll probably do that. They'll probably do it. They'll already have it in factor form. You're like, well, that's easy. It's already factored for me. Well, what if you don't realize it's already factored for you? Then you might not see. Huh? Yeah, but where is that? Where is 3 over 2? It's between 1 and 2 because it's crossing at 1. 3 over 2 is equal to 1.5. Yeah, if you divide 3 by 2, you get 1.5. So that means it's crossing in between there. Did you have some last night that were crossing in between? Yeah, you did. Okay. or yesterday, you had some crossing. Where's negative 4/5? Oh. Put it in your calculator. Divide 4 by 5. Logan. You, Logan. 0 and negative 1. Negative 4/5 is negative 0.8. And so where is that? That is in between 0 and negative 1. So that is where it'd be crossing in between. Okay? How can you put what in your calculator? The problem, you can put the whole thing. Like, you can FOIL it out and get the actual problem. Does that make sense? Or you can put in y equals parentheses 2x minus 3, close parentheses, parentheses. The calculator will FOIL it for you. Okay, but it will. It'll do it for you. Okay? All right. Take a look at this one. And again, problems like this, to me, I can see it. What are my factors going to end up being? Negative 4 and positive 4. So what are my answers? 4 and negative 4. You with me? So when you factor, this is a difference of two squares. This is x times x. This is plus 4. This is minus 4. So what would make this part 0 if x were equal to negative 4? And this would become 0 if x were equal to positive 4. Can anybody tell me another way to write this answer that you may see on a test or on an SOL? You can do squigglies, brackets, sets. Okay, anybody know another way? Sometimes you see something like this. Okay, and this means plus or minus 4, positive or negative 4. If it's the same number and one's positive, one's negative, sometimes you might see that. So make sure you know that that just means positive or negative 4 is your answer. Yeah, that is. That's a positive 4 and that is a negative 4. It means your answer could be either one. And you'll see it more on Monday because it's in our formula on Monday. Negative b plus or minus square root of b squared minus 4ac all divided by 2a. So, that's Monday. It's not. It's not. Okay. What if you have one that looks like so? You gotta move it over and then what? Do you add 7 and a squared? So can I factor like that? What's wrong with it? It's not in order. So you make sure if it's not in order, you put it in order. So what would come first? A squared plus 7a plus 10. You try this one on your own. Factor it. It starts at 10, so we'll go soon. Okay, so this becomes a plus 5 and a plus 2. So what are our answers? Negative 5 and negative 2. Okay, and again, this would be crossing at negative 5 and negative 2. Okay, all right, try this one. Just a couple more. Right. Anybody have questions with my factoring? Did everybody come up with at least it factored correctly? Yes. From here, you need to set it equal to 0. Now, this one's easy to see. What would make that 0? X is negative 1. This is one where you may need to set it equal to 0 because, and it's because of this 5. When you move that over, you get 5x equals 2, but when you divide by 5, x would equal 2/5. Okay. Do you have any questions? Do you see that you, because of the 5, you have to move it over? And if you put a 2/5 in, it would work. Okay, if you plug the 2/5 in here, 5 times 2/5 minus 2, what happens to the 5s? They cancel, and 2 minus 2 is, which is what you want. Does that make sense? Okay, questions? All right, just a few more. What if you have one that looks like this? Gotta think. Try that one. So when you factor it, this comes out to equal x times x and plus 4 and plus 4. Everybody agree? Aha! But what do you notice? These are the same. Do you need to set both of them equal to 0? No, your answer is just -4. So if you graphed it, 1, 2, 3, 4, this is a U because it's positive. It's one of those one solution problems, okay, if you end up with the same thing in both of the binomials. Okay? All right, so what I'm going to do is I'm going to give you some practice. That way I'm going to go ahead and give it to you so that I can come around and help you with it.